Okay, welcome to Saga, the system for automated geoscientific analysis. Saga is a really cool software, and what I'm going to show you here is basically kind of working you through your lab. Lab's going to be one of those pass fail. I did it, I didn't do it kind of grades. Um, be aware that doing this is going to take a little bit of time because some of these functions and tools, when you're looking at a really large area, even though Saga is designed for it, still going to take some time. So mostly we're going to look at hydrology and some of the other stuff, but it all kind of relates to land surfaces, and Saga is really good at being able to work within that context. So why would you want to learn it? Well, it is free, it is simple, it is robust, it works really well with big data sets, and it has a lot of really unique and interesting tools. Being designed in a freeware environment, people come up with the latest, newest, coolest, most interesting way to calculate something from a digital elevation model. Someone makes a tool for it in Saga. That happens pretty frequently. It has specialized tools just to deal with big data sets. It does not allow you to do more than one thing at a time. So you run a tool and you simply can't do anything else until that tool finishes running. There's no bells, there's no whistles. It's crude in that respect, in that it doesn't have much in the way of that kind of stuff. But that is how it becomes so robust and so capable with dealing with big data sets. So let's look at it. What's unique about it? The layout's kind of different. You get something that looks very much like this. There's a bunch of little small displays that tell you things. The one on the bottom shows what you're doing or what you've done or what's finished or what hasn't finished or what didn't work. Properties, when you have data, it tells you all about it. The Tools tab shows you the tools that you can work with, and the maps show you the various maps that you can make. The Data Source section shows you where everything's at. Not a lot of interaction here. Definitely not a Rolls Royce. It's not all luxury. It's more like a drag racer. Big motor and big wheels and a seat, and you just click run and it goes in a straight line. So the tools, they're all in one menu. They're very descriptive in nature. Um, if you think like you're looking for stuff in Esri, you're never going to find anything in Saga. Look for what you're trying to do. There's lots of options, and when you run the tools, they can be a little tricky to use. I'll show you tonight in class. I'll fire up a tool or so just so you kind of get to see how how it goes about working, because that can be a little bit of a problem. There is very limited help. When you can find it, use it. Individually within tools, there's information usually explaining what some stuff is or what paper documents what these things mean. And that's about all you get. Um, Probably the best thing is, if you're going to do stuff in here, it's almost, or at least for me, I almost exclusively use it for working with digital elevation models. I'm sure it can do other things, but I think this is where it really shines. And the best way to load a elevation raster, there's about 1,000 different ways to load data, and none of them work real well because they're geared towards very specific data sets. If you grab a DEM from a folder and just drag it over your Saga map and let it go, it'll load it up. So we're going to work with the DEM just to do some basic hydrology stuff, and we're going to do some landform, deep stuff as well. But the first thing that you need to remember is you always want to pre-process your data for hydrology. And the reason is hydrology is based on this network concept of things draining to somewhere, and sinks or places where everything drains to that doesn't have an output. They don't work for most of these analysis. So the first thing you have to do is find all those things, and then slowly you raise the value of that particular cell up until it drains to somewhere just like everywhere else. Now this is a relatively mundane task on a small data set, but on big data sets this is a bear. So we'll take a look at this, and I'll tell you that if you have the state of West Virginia at 30 meters, it'll take about 3 minutes to do this. And that's not too bad. Some tools are actually sets of tools. For example, like if you see the basic terrain analysis, it makes 14 different layers of data, and so that's going to take a while. On my crappy laptop at home, last year, it took about a half an hour to run that one tool. That one tool created 14 different layers for me. Saga only runs one program at a time, so you can't, say, well, I'll run this, and then I'll run this, and I'll run this, and you have things competing for resources. Not only does it not do that, like ArcGIS would run them all, or it would, run the next one only after one finishes. No, this one literally won't even let you start another tool until the one that you are running finishes. So that's kind of the basics of what we got here, and so what I'm kind of wanting you guys to do for the lab is to explore a couple of things. The Saga Wetness Index, I want you to look at the fill sinks and the fill sinks XL. We'll look at some curvatures and some watersheds and some basin stuff maybe. When you open up Saga, it's going to look kind of like this. I drug in a DEM of West Virginia, and I had to click on the data tab, which is there on the left just underneath the top header. And once I did that, it showed me what was there, and I went down to where it says 0.1.prj. And the reason it knows is that's because I had to open up a digital elevation model, and there were several files there. And I simply grabbed one of them and drug it in, and the one that I drug in happened to be called that. It then accesses the folder where it came from and figures out all the other stuff to display it. And after you get your data in place, you can then start to look at tools. And so if, for example, you wanted to run the Saga Wetness Index, remember what I said earlier, first thing you got to do, pre-processing your data. So when you look under pre-processing, you see sink removal, sink drainage route detection, flat detection, fill sinks XXL, fill sinks, lots of different ones. So there's different ways that you can do this. And so, try one of the early ones like fill sinks, Planchon, and Darboux. And then try the fill sinks extra large, Wang and Liu. I can't guarantee that the first one will even run on a data set this size, but fill sinks extra large will. If you're looking at shuttle tomography radar data, so elevation models like the ones we used last week, I would definitely use the fill sinks XXL. There's also other really cool stuff here in the terrain analysis section. Morphometry, which has to do with the shape of the land, and hydrology, which is all about water movement, is the ones we're going to look at. I wanted to show you what one of these tools looks like. This is the Fill Sinks XXL tool. And so when it pops up, initially, everything is blank. And so where it says grid system, and the other side, it's just going to be a blank the whole way across. But once you click in that blank, there'll be 3 tiny dots that will appear at the far right. And when you click on that, it'll give you some options, and one of them will be eventually figuring out and finding the data that you want. You'll select it, in this case from the drop down, and it then put that in place, that was the DEM. The first one above, under grid system, it wanted to know the extent, and the extent is what it measures the extent to be based on the only data set that's in the data set, or in the software, which at the time was the DEM. So I set the extent, and then I selected where my elevation data would come from. That was the PRJ file that I used. And then the field DEM, and I just told it to create it. So it's going to make the file. Anytime you have an option and it says create, it means it's going to create that. If you don't want it, you can change it. If you already have it, you can identify it. If you want one, just leave it alone. As far as the options and all that kind of stuff, you can go to the defaults and all that stuff, and you can see down here at the bottom, when you click on the things, it tells you what they are. You click on the DEM tab, down at the bottom it says DEM Grid Input Digital Elevation Model. It's just telling you, explaining what it is. These tools, these GUIs, are very basic, and they're not consistently put together with equal amounts of assistance and help. Some have a lot of details, some have almost nothing. So be careful. Once that finished running, I got the projection layer with no sinks, and it basically looks really similar to the other one, but it's not. It's been modified somewhat. So as far as some of the tools that I want you to take a look at, under morphometry, there's all kinds of interesting stuff in there. Things like a convergence index. Just going down the list, looking here. Slope, aspect, and curvature is a good tool to think about. Topographic position index would be something to look at. Terrain surface classification. Terrain surface convexity. These are all things that explain and express the shape of the landform. Under hydrology, obviously I want you to run the Saga wetness index. This is a very special version of a topographic wetness index, and a topographic wetness index looks at how water accumulates based on flow direction. And so we've got this DEM that always drains to somewhere. And so as one cell drains into another cell, then the volume of that cell increases because of what drained into it. And so it'll go through this process of figuring out where water will flow. And then it does a calculation based off of slope. And essentially what you get is places that have a lot of upslope area leading to it that are relatively flat end up with a higher index value, meaning that they're likely wetter than places that have a lower index value. And that's all that works out to. But there's lots of things like this you can look at as well. So I want you to look up a couple of these tools. Just Google them: convergence index, slope aspect and curvature, basic terrain analysis, Saga wetness index, analytical hill shading. These 5 tools will generate a lot of data, and it will probably take you a couple hours to run all this stuff. But all I'm going to ask you is to do it, and then let me know which ones worked and which ones didn't, and I'll put up a thing in Canvas for you to do that, or which ones you had trouble with, which ones you didn't. But at the end of the day, what you're really looking to do is twofold. One is to understand how much information you can extract from a digital elevation model. It is literally mind-blowing when you think about it, the amount of things you can determine, that you can calculate, that you can measure from elevation. The second is to realize if you want to do really, really interesting stuff, you have to kind of get away from the sort of canned available softwares that everyone else uses, because they're made to meet the minimum needs for the most people. And what does that mean? That means They develop the tools that will get the most use by the most number of people. They don't develop the tools that are the newest, the interestingest, and the most cleverest. They aren't as worried about a convergence index. Okay, maybe not enough people worry about that. They're not interested in some of the limitations of a lot of the traditional topographic wetness indexes, and so they just have the basic topo wetness indexes. They don't have the Saga wetness index, which is actually a modified version of it, and it has an infinite amount of options. Not infinite, but they have many more options you can use to change it and make it better for specific things. So if you are going to get into more of a hardcore level of analysis, at some point in time you're going to ask yourself, is this the best way to do it when you're looking at something in a software like Esri or even some of the other commercially available GIS softwares? And sooner or later the answer is going to come back no. This is not the best way of doing it. It's just the way that's the easiest or the most efficient for the most number of people who want to do this. It doesn't mean it's the best way for you. And if there's a better way, and there's a better way, places like Saga are likely where you're going to find those. And that could be of trivial importance or it could be paramount. But Saga is an easy enough program to learn and it's free, so I think it's worth your time to look at some of these things, and maybe it'll spur an idea as far as a project. For example, I'm trying to think of what might be a good one. Well, if you're looking at building site locations on a mountain, you don't want to be in areas that collect water. You want to be places that shed water. And so things like slope curvature matter. So if it's convex, in other words, it's bulging out up to down and side to side, it's not going to collect a lot of water. It's not going to stay wet. Whereas if mid-slope you're in a concave, yeah, it's probably going to get a lot wetter. Now, how could you figure that out? Well, you could do some of those curvature things and look and see what you're actually seeing. You could calculate a wetness index and look for high values. Lots of different ways. But again, thinking about what you might do for a project, there might be a tool or something that's in here that would be more useful than what you have available with Esri. So again, I think it's worthwhile to learn.